Usually, when a major AI model gets updated, there's a big launch moment. You get an executive on a brightly lit stage, benchmark charts on screen, and a full breakdown of new features in front of millions of people. But XAI did the exact opposite. Instead of making a big announcement, they quietly updated their developer systems and slipped Grok 4.3 into production. It didn't show up in major public release notes, but the back-end developer documentation tells a different story. In that documentation, XAI tells developers to use this exact model for general text workloads. That matters because when a company makes a model the default recommendation, it usually means they see it as the most reliable baseline for everyday use. So instead of pushing a flashy consumer feature, XAI appears to be repositioning its core model around the infrastructure developers actually build on. And this strategy is built around three main ideas: changing the default model recommendation, improving the model for autonomous agents, and cutting the cost of running those agents. This compares early AI with the newer agent era. On the left, you have the traditional chatbot path, a simple linear flow where the user asks something and the model returns one block of text. On the right, you have the agent loop. This is where the AI reasons through a task, calls external tools, checks results, and decides when the job is actually finished. That shift is important. It suggests that the value of these models is no longer just about having a good conversation, it's about whether the model can reliably complete multi-step software tasks. This schematic breaks down Grok 4.3's architecture. It starts with a 1 million token context window. Then, it adds always-on reasoning. And finally, it uses a stateful responses API that can store conversation history on servers for 30 days. That makes it easier to chain together longer, continuous interactions without developers constantly rebuilding the same context. This flowchart shows the pre-built ecosystem an agent needs in order to operate. Grok 4.3 acts as the core intelligence, connected directly to tools like web search and code execution. That means the agent can route tasks based on complexity instead of treating every request the same way. This shows how the model handles messy information. It can take unstructured text, parse it, and force the output into strict JSON. That might sound boring, but for developers, it's a big deal. If the output always matches a predefined schema, the AI's results can be passed directly into software systems without breaking the pipeline. Because in an automated workflow, raw intelligence is not enough. If the model formats the answer incorrectly and the downstream database can't read it, the whole system can fail. But there's another problem with autonomous agents: cost. These systems can burn through money very quickly. This sequence shows how an agent's costs build up. Input tokens are usually the cheap part. The real cost starts to compound when the agent generates lots of reasoning tokens and calls tools over and over again. And the biggest bottleneck often comes at the end. When the agent has to turn everything into a structured report, it can generate thousands of expensive completion tokens. So if one multi-step task creates thousands of internal reasoning and output tokens, the price of output tokens becomes one of the biggest factors in whether an AI product can scale. This matrix compares API costs across frontier models. For many leading models, generating 1 million output tokens costs somewhere around $15 to $25. Grok 4.3 brings that down to $2.50. That 6 to 10 times cost difference changes the math for products that generate a lot of output. This maps intelligence against running cost. When you compare Grok 4.3 to the previous version, you see something rare. The new model scores higher on intelligence while also operating at a lower cost. Looking at real-world software tasks, this bar chart shows Grok 4.3 making a 321-point jump over the previous version in agentic benchmarking. That points to stronger instruction following and better support for software workflows. But there is a trade-off. This shows that while the model gained 8 points in general omniscience accuracy, its non-hallucination rate dropped by the same amount. In simple terms, when the model is pushed to the edge of what it knows, it may be more likely to produce unsupported answers. So the lower cost is powerful for developers, but it still needs guardrails. For high-stakes use cases, you would still want human review and validation in the loop. This diagram maps the current competitive landscape. OpenAI still sits in the broad, heavy-duty enterprise lane. Anthropic is positioned more like the careful coding engineer, and XAI seems to be carving out a third lane with Grok 4.3, the high-volume agent engine. This brings together what modern AI products actually need. You need native server-side tools, you need always-on reasoning, and you need output costs low enough that the product can actually scale. When you combine those pieces with a 2.50 output token economy, you get the foundation for a scalable production agent. The biggest AI companies are no longer only competing on peak intelligence scores. Those scores still matter, but intelligence is becoming more of a baseline. The real advantage is shifting toward deployment economics, and this final summary shows what that means for the development stack. By combining built-in structured outputs with much lower output costs, complex automations that used to be too expensive are now much more financially realistic.